Hello, algebra students. It's Miss Broad again. We are watching video 19 and you are on page 33. So go ahead to page 33, please. And you are watching video number 19 right now. So we've been graphing inequalities, and what we're going to get into today is graphing systems of inequalities. So what that means is you're going to graph more than one inequality on the same graph. So 1A says to graph the system of inequalities. So I'm going to graph both of these in the same graph. So my first step when I'm graphing is to pull out my M value and my B value because I already have the Y alone. So M is always in front of X. Remember, M stands for your slope. And my B value is the Y-intercept, which is the number all alone, which is 3. So I'm going to start on my Y-axis at 3. My slope is then positive 2 over positive 3, so I'm going to go up 2 because it's positive, and right 3 because it's positive. So I'm going to keep going as many times as I can fit. Up 2, right 1, 2, 3. Up 2, right 1, 2, 3. Up and to the right is the same as going down 2 and left 3. Down 2, left 3. Down 2, left 3. Now remember, I made a mistake there. I only went over, so I need to go over, so down 2 and then 1, 2, 3 to the left. So down 2 to the left, 1, 2, 3. Okay, so when we're graphing inequalities, they're different than graphing equations because you have to remember solid line or dashed line. So remember when we have this or equal to line underneath my inequality, it's going to be a solid line. So it's a solid line because we have the or equal to underneath the inequality symbol. I now have y is less than or equal to. So if something is less than, I'm going to shade below. So I'm going to shade below my graph. I'm going to go down. And this is when it becomes incredibly important to label. So we're going to write that inequality, y is less than or equal to 2/3 x plus 3. So we have to know which line is which that we're graphing. So this is why I have been stressing to you guys to label. All right, my next inequality that I need to graph already has the y alone, so I can pull out my M value and my B value. So my M value is always in front of X. M is 2. I want to make my slope into a fraction, so I put it over 1. My B value is the number alone, which in this case is a -2. So B is where I begin. So I'm going to start at -2 on my y-axis. My slope is then 2 over 1. So positive 2 tells me to go up 2. Positive 1 tells me to go to the right 1. Up 2 and to the right 1. Up 2, right 1. Up 2, right 1. Up 1, 2, right 1. And going up and to the right is the same as going down 2 and left 1. Down 2 boxes, left 1 box. And I do this as many times as my graph can fit. So now in this one, I don't have the or equal to line underneath my inequality symbol. So that's when I have a dashed line or a dotted line. Whichever one you want to call it. So we don't connect all of our points. We use a dash or dotted line. I then have to worry about my shading again when we're graphing inequalities. So this says y is greater than. So if something is greater, I'm going to shade above. So I'm extending my lines all the way to the edge of the graph. And of course, label, label, label. So y is greater than 2x minus 2. So we did part A. So now part B says to label the solution set S. So the solution set for a system of inequalities is where both shaded areas are crossing. So the solution set to my first inequality was down in here. But this section here only has the black pen. My solution set for my second inequality was everything above the line, which is in purple. So this section here is only purple. So I need where I have the black pen and the purple pen crossing, which is in this entire area here. So my solution set is where my purple and my black lines, my shaded areas, are crossing. Part C says circle the points that lie in the solution set of the system of inequalities. So if I go to the point 0, 0, that's the origin. So that point falls into this space right here. So I'm going to circle it because it is in the solution set. If I go to the point 4, so positive 1, 2, 3, 4, and then down 2, 1, 2, this point here is only in the solution set with the black shading. So that is not in my solution set. I then have the point 0, 3. So I'm going to go 0, but then I don't go left or right because my x value is 0, and then I go up 1, 2, 3. I'm going to write something that I would like you to write. So put a star, and I'd like you to write a point is in the solution set if on solid lines, but not if on the dashed or dotted lines. So a point is in the solution set if the point is on solid lines, but not if the point is on dashed lines. So this point right here that we went to was on a solid line, so this would be in my solution set. So then I have the point 0, negative 2. So 0, negative 2 says I'm not going left or right, but I'm going down 1, 2. That is on a dashed line, so based on what we just wrote, it is not in the solution set, so I'm not going to circle that point. All right, we're gonna go ahead and take a look at, let's see, we will take a look at number 3. So we're gonna skip over to page 34 and look at number 3. All right, number 3 says to graph the system of inequalities and label its solution set A. So in the first inequality they give us, we do not have the y by itself. So I need to solve this for y. So I need to get everything without an x on the same side of my inequality symbol. I'm sorry, everything without a y, my apologies. So I'm going to minus the 3x from each side. I'm just going to rewrite it down over here where I have more space. So now I have negative 2y is greater than 6 minus 3x. I now need y by itself, so I'm going to divide all 3 terms by negative 2. Oh, my phone's ringing, but I'm just going to let it go so I don't stop the video. I don't want to interrupt class time for you guys. All right, so my negative 2's cancel. I now have y. Remember, we have to flip our inequality symbol or switch it, so it was greater than. It now becomes less than because we're dividing by a negative number. So now I have 6 divided by negative 2, which is a negative 3. Then I have negative 3 divided by negative 2, which doesn't give me an even number, but it gives me a positive 3 over 2x. So now that I have the y by itself, I'm going to pull out my m value and my b value. So my m is always in front of x. M stands for slope or rate of change. My m is 3 over 2. My b is negative 3. So b is where I begin, so I start at negative 3 on my y-axis. I'm going to rise 3 because it's a positive 3 and run 2 to the right because it's a positive 2. So up 1, 2, 3, right 2. Up 1, 2, 3, right 2. Up 1, 2, 3, right 2. Going up and to the right is the same as going down and to the left. Down 3, left 2. Remember, we're graphing an inequality here, so we want to make sure that we remember, okay, is this a dashed line or a solid line? So I've seen some people create little note cards that wrote down, they use as a cheat sheet, which is a great idea. So remember, if there's no line underneath this, we're using a dashed line or a dotted line, whichever you prefer to call it. Now, when we shade, we're basing it on what I solved for. So when y is less than, I'm shading below. And when we label, we're going to label with the original inequality. So I'm going to write the 3x minus 2y is greater than 6 on this. Next one we have is y is greater than or equal to 4. So when I just have y and a number, I'm just going to that number on the y-axis. So I'm going up 1, 2, 3, 4. I then have the or equal to line underneath, which means it's a solid line. I'm going to shade everything that makes this true, right? My solution set that's shaded is everything that makes the inequality true. So y is greater than or equal to 4. So everything that's greater than 4 is above the 4. So I'm shading above the line. And then the last step says to label its solution set A. So the solution set is where the purple and the black lines are crossing. So if I look at this section here, I only have the black shading, so that's not my solution set. If I look at this section, I only have the purple shading, so that's not my solution set. But if I look at this section here, I have the black lines and the purple lines crossing, so that is my solution set. I'm going to label it A. So where your shaded areas are crossing is your solution set. So part A is done. Part B says state the coordinates of one point that lies in the solution set. So like I said, we can pick any point in here that is in the solution set. So if I went over 1, 2, 3, 4, 5, 6, 7, and then I went up 1, 2, 3, 4, I could pick this point right here, because remember we said that if a point is on the solid line, it's in your solution set. I could also pick the point 7, 5, because that's one above, and that's in where my shaded areas are crossing. So there's many, many options you could pick for that. Now part C says to state the coordinates of one point that does not lie in the solution set. So we learned in the last video that if a point is on the line, on the dashed line, it is not in your solution set. So if I picked this point right here to get there, I would have to go 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4, 5, 6. So this point is not in my solution set because it is on a dashed line. All right, we're going to skip over to page 35 now. And we're going to take a look at number 5. So number 5 says, which ordered pairs are in the solution set of y is greater than -1/2 x plus 5 and y is less than or equal to 3x minus 2, justify your answer. So what I need to do is I don't have a graph here, so I'm going to do this algebraically. What I mean by that is if I have a point, I have an x and a y, I'm going to plug those in to my inequalities and see if it makes them true. So I'm going to use a pencil for this so that I can erase. So where the x is, I'll be putting in a 5, and where the y is, I'll be putting in a 3. So in my first inequality, I have y is 3 is greater than -1/2 times x. X in this point is 5, and then plus 5. So if I did the math on this, I would get -1/2 times 5, and then I add 5 onto that. So remember, when we're doing fractions in our calculator, we're using parentheses. So -1 divided by 2, close the parentheses, times 5, and then plus 5, I get 2.5. So is 3 greater than 2.5? Yeah, it is. So this could be my answer. But now I have to go and make sure that this point also makes this inequality true. So where y is, I'm plugging in 3, is less than or equal to 3 times x, x in this case is 5, minus 2. So is 3 less than or equal to? So I have 3 times 5 minus 2 is 13. Is 3 less than or equal to 13? Yes, it is. But we have to be very careful. This was a tricky question. It says, which ordered pair? So I'm actually going to have more than one answer here. And it said to justify my answer, so I need to show my work. So this does work. So choice 1 is one of them. So now I'm going to do choice 2, but I'm going to erase my x's and my y's so that I don't have to do the whole thing over again. So now in this case, I have x is 4, so where x was is 4, and where y is, oh, I could have left the 3's That's okay. So let's see, now we're gonna do, again, for a fraction, you're doing parentheses, -1 divided by 2 times 4, and then plus 5, and we get 3. So is 3 greater than 3? No, because it doesn't have the or equal to line. So this point does not work. So we're not circling choice 2, and we don't even have to try it in the other inequality because it doesn't work in the first one. All right, choice 3. So I'm gonna erase my x's and y's again. All right, so where x is this time, I'm putting in a 3. And where y is, I'm putting a 4. Okay, so now I have -1/2 times 3 plus 5. So is 4 greater than 3.5? Yes, it is. So this one could work, but now I need to try it in my other inequality. So where x is, I'm plugging in 3. Where y was, I'm plugging in a 4. So now I have 3 times 3 minus 2, which gives me 7. Is 4 less than or equal to 7? Yes, it is. It's less than. So this point also works. And now we're going to do the same thing with, I can leave the 4s because my x and y are both 4s this time. Okay. So I have a 4 for x and a 4 for y. So if I do parentheses for fractions, so parentheses -1 divided by 2, close the parentheses, times 4, and then plus 5. Is 4 greater than 3? It is. So this one could work, but now I need to also try it in the second inequality. So this time I have 3 times 4 minus 2, which is 10. Is 4 less than or equal to 10? It is. This point also works. So we have to read carefully, right? Half a math test, half a reading test. So now you guys are going to go and do page 36 and 37 on your own. So for video number 19, you are doing page 36 and page 37 on your own. As always, message us on Schoology. Keep up the good work. We're really proud of you guys. Have a good day.